Hi everybody. Okay, so for this lesson we're going to learn about objects. At this point you pretty much have the programming basics down, and those will apply pretty much to any programming language. There might be some specific syntax that's different, but you've got the basics down at this point. You've got variables, you've got functions, you've got calling functions, you've got loops and conditions and branch logic. And that's pretty much all there is to programming, and then it's just a bunch of that piled together to make bigger programs. So you've got all the basic building blocks at this point. Now Java is an object-oriented language, and that means it's you break things up into objects that have functionality, and just it helps you maintain the projects programs a little bit easier. So we're going to start covering that stuff. So this is the point now where we start putting all that we've learned together into creating programs. And in Java, the way you create programs is with objects. So at this point, we're going to start, for the next few lessons here, we're going to start actually building programs with what we've learned. We've been doing that along the way with our exercises, and now we're actually going to start putting it together into objects, which Java is all about. Okay, so you've done a lot of this stuff already throughout. You can't really get away from it. So you've already done things like the new keyword. You've created new instances of objects. We're just going to describe it in a little bit more detail here. So a file object is a class that's built into Java. You can make your own file object too. It's as an object-oriented language. You can create your own objects, your own classes, whatever you want to do. But so the new keyword is how you start an instance of a class. So say you have a class. It's a definition of what an object can be, and you could have several of those with different, in this case, different file names. So you could have 3 different file instances, file objects, and each one has a different folder or file name. And so that's pretty much how those work, and you create those with the new keyword. Okay, so then you can call functions, and we've been doing this as well. So you call functions on another object. So this is another object here, so we're going to say this is a program that we have, a class that we've made, and this could be our main hello world that we've been using. And we create a new file, sample.txt, and then we're going to call this function on it. Does this file exist? So you can say, I have a file, it's named this, and you say, is it actually there on the hard drive? And that's what this function is. And so that's how you call functions on another object from an object. Okay, object equality. Now this is a little bit tricky in Java. Equality is 2 different things. The dot equals is what we use to compare objects together. So you could create a new string, hello, and another string with the exact same word, and so that should be equal, right? But if you actually print out our equality operator, the double equal sign, A equals B, this is false. Now why is it false? Because in Java it's comparing the base identity of the object. So here it's getting the ID of the object. Is A equal to B? Well, no, but they're 2 separate instances. They're not the same instance, and that's what this is checking. So when you're working with objects, you actually want to use the dot equals function. Now it's same set of strings here, hello and hello, A and B. Now we're going to say is A equals B with the function, and then it gets to true. So then it's actually seeing, are these 2 things equal? Hello does equal hello. And so that evaluates the true. So remember that. This double equals works great for numbers and primitives. Doesn't work great for objects. You need to use the equals for objects. Okay, now variable scope. We learned about variables. We know how to assign them. Now, how are they visible? Some are visible in different contexts. So a class, which we've gone over already, so the anatomy of a class. And a class definition starts with these brackets, right? So this bracket here and that bracket ends it. So for class scope, which is what the one we're talking about now, any variable inside of the first bracket pair is visible to any other code inside of this class. So in this case, the variable name is available in the constructor, it's available in the in a function, and it's available in another function also within another code block, which is this for loop. So if you define it at the class level, and sometimes they call this member level, that variable is available anywhere within this class. Now function scope is smaller. Within this print function, name is not visible. I don't even see where name is defined here because it looks like I left it out. Oh, no, I didn't. I put it down here. So name is in this defined down in this function here. And it's visible in this for loop block here because when the variable is defined within these two bracket pairs, anything inside of the bracket pairs can see that variable. So name here is visible to this for loop, but it's not visible to this other function up here because it's not defined at the class level. It's defined in the function level, so only visible within this function. Loop scope is a little bit tighter, so we're going smaller now. This j variable and this I variable are visible within this for loop. So anything from for inside of this for configuration and its brackets is visible within this for loop, but not outside of it. So these two brackets right here have the visibility to anything defined within this for loop here. And then there's bracket scope. So anything that's inside of brackets. So you've got an if condition here. Here's two brackets. And chars is only visible inside of here. And letters is visible here because it's within this function block. So this is a bracket, set of brackets inside of a function. So that's where this is defined. So you see here this variable, and the way to tell is you can say, okay, here's the variable here. What's the next bracket up from it? Okay, it's this one. Where's the closing bracket here? Anything inside of there is visible. That variable is visible. Okay, object-oriented languages. There's a trait or an ability about objects in that they support inheritance. So what that means is if there's a class in Java that's defined either in the base language or some library that you're using, and it's not declared final, because you can call it final, which means final means you can't extend it. Otherwise, it's extendable. So you can go ahead and grab a class, say mammal, and extend it with lion. So you can create a new class from an existing class, and that's how you keep building on functionality. And that's how programs can get more complex. And then also you have libraries that allow you to build more powerful programs, and you can extend the library if it doesn't do what you need it to do. And it also helps you organize your program. So in the case of inheritance here, we're using mammal as the base class, and lion is the subclass, and it's extending the functionality. So mammals all have hair or fur, and so this is a trait of a mammal. And then a lion extending mammal, so being a mammal, but more specifically a lion, also can roar. So this is extending mammal. So in this example down here, if we're testing out inheritance in our main program, we can create a new lion, and then we can see that it has hair or fur, which is inherited from the mammal class that it extends. Now composition is preferred over inheritance because in Java you can only inherit from one parent class, and that gets pretty tricky if you get too deep in inheritance or your program's really complex where you're trying to use a hierarchy of inheritance. It's really, really difficult, and it gets kind of unmaintainable. It works in some other situations, but for the most part, the more flexible way to go is called composition. And this is by implementing interfaces, so using the implements keyword in Java. So when you create your class, you're actually implementing traits called interfaces, and that's how you can have multiple inheritance in Java. And it's just more flexible and more maintainable. It's if your program gets really big, inheritance makes it a little bit harder. You can still use inheritance, but overall you don't want to just say we're strictly doing inheritance because it does get too difficult as your program gets bigger. So composition is the way to go. So let's take example. Let's say we're building out users, right? So they have logins, they have names. So let's say in some contexts we want the person. We don't care that it's a user. We just want the person's name, and we don't care what their password is. We don't need it. So that would be the person context or the person interface. Same thing with login. We have usernames and passwords. For logging somebody in, don't necessarily care about their name. We just want to see if they have a username and password and it matches. So that's a login context or a login interface, and we don't really care about the name at that point. Now, the user is the implementation of a person and a login, and that's how the program gets stored, or sometimes we use it in a user context where a user has a username, a password, and a name. So we're going to implement person, we're going to implement login, and we're going to call our class user. And so this gives us the ability to have a user implement two different contexts. So this is a constructor, which you've seen, and here's the variables. And we're going to set it, so anytime you call a new user, you're going to give it a name, a username, and a password. And then here's the getters for those. Now, let's say that we have a login service. So this is our user service and allows us to authenticate a user when they log in. So the password has to be equal for this user to have a successful login. So our user service, and we're not using a database here, we're just going to go ahead and use it as a map. And we're going to create a user called Wally, wally@gmail.com, and the password is ABCDEFG. And we're just going to add that as if this is a database. And then when we call the authenticate function, it's just going to take in the login information, which is username and password, and it's going to get users by this username. And then if the password, remember, .equals user's password, then we're going to return the user, which is, in this case, going to be sent out as a login, but it is in fact the user because that's how we're storing it. If it's not found, we're just going to throw an exception. In our case, stop the program, and we'll just say user not found. And so here's us testing out that login. So we're going to run main. We're going to pass in the username and password. We're going to access our user service to authenticate. And then we're going to get our login. And if the login's good, we're going to print hello. We're going to cast it here to a user. And that's probably not, this is a contrived example, but you can get it as a user, so you can get to the name. We're getting it as a login from the authenticate service, or the authenticate function, but here it is as a user, so we can get the user's name and say hello, whatever the username is, in this case Wally. Alright, so that's how that works. I think what we should probably do is, what I'd like you to do anyway, is go ahead and implement this authentication service. Now, I typed this out without actually programming it, so hopefully it all works. If it doesn't, it's great exercise for you to figure out what is wrong. I think for the most part it's right, but there might be something in there, and you could call it a game almost. Is it right? And so implement this composition. So you're going to make these classes, and remember, class name has to match the file name, right? And so go ahead and pause your video and try to do this exercise, and then I'm going to record it, me doing it, so you can watch it along and see if your solution is the same. Okay, pause your video. Okay, so we're back, and now I'm going to start going ahead and implementing this. So I'm going to open up Visual Studio Code, and I'm going to start creating, it looks like I'm going to create 4 classes here, so 2 interfaces and a implementation class, and then I'm going to do a user service, and then for the 5th one we're going to use, I guess we'll create a new one, because now we're going to start practicing. We won't use our Hello World program anymore. Now we're going to start building real programs, so let's go ahead and build that out. Okay, so let's try and do as much as we can from our understanding of the problem. Try not to copy and paste any of this, type everything, and also try to see if you understand the concept. We've got, and so it's kind of simple. We've got a login, username and password. We've got a person, just has a name, and we're going to call that a user. We should be able to type that out just by thinking as we're programming. So now you're going to start learning to think like a programmer and not just following along with some tutorial. All right, so let's go ahead and open up our editor. This is our Hello World program. Let's go ahead and just create our new set of classes, and it looks like I'm not in any kind of folder, so let's just close these all together. So we've created multiple classes before. And let's just use our keyboard. And we're going to clear this out too. So if you type clear in the terminal, it'll just wipe that out. Okay, so now we've got a blank editor. So I'm going to hit Command New, and it's it's Command N, and it's Control N on Windows. All right, so let's start a new class, and trying to do this from our understanding, not memorizing what's in the tutorial, but our understanding is that we need a login class and a person class as interfaces, and that's going to be implemented by the user, which is where the details will go. All right, so let's do that. So let's create a new class first, and we've got a file here. So let's call this one person.java, right, because it's got to match the name. We'll save. And we'll just leave it right there in whatever folder it is. We won't use packages yet. We'll get into that soon enough. All right, so then now you're going to go from what you've learned. So public class, right? We need a class first, and this is called person. And it starts with brackets. So now we've got our first set of brackets there. And person is going to have a name, and we're going to keep the name private here because you don't want anyone accessing these details. You'll provide a getter or setter for that. And now this is an interface, so the interface doesn't have the scoping like that. So string, and it's going to be name. And so that is specifying what our interface is going to have. And I put the word class here, and that was wrong. This is actually interface. And why doesn't it like that? Blank final field may not have been initialized. Of course not, because this is an interface. Oh, we don't need public either. And we don't have variables here. This is actually an interface. So see, even I am forgetting how to do this. So if you have to refer back to the tutorial, go ahead. Or you could just fumble along like I'm doing. So string, this is an interface, so it needs to have a function. So this is how we want to implement that. And now it's happy. So at least the IDE is helping us out a little bit. All right, so we're going to have a function named getName in our person interface. All right, so that's that. So let's go ahead and make our user class now. So I'm going to hit N. I'm going to create user.java. And this is a class this time. And it implements person. So some IDEs complain. I don't know if this one will. If you don't have the implemented methods, and this one does not complain that I know of, but maybe it does, and I just don't know how to make it complain. And by complain, I mean it tells me that it's not implementing the interface. And sometimes you can discover it by, if I click on person, nope. All right, so let's implement the interface here. And by implementing it means make the code the way it should be. The interface just defines what the name of the thing is and what it returns. And now we have to put in the body of it. So here we'll make it public because we want it to be visible. And it's going to return a string because that's what the interface says, and it's get name, right? Because that, and now we can refer back to this. So it's get name, and we're going to return a name variable. Now here's a problem. Where's our name variable stored? We don't have it. So this is kind of working. It's not really working backwards. It's working iteratively, and it helps self-discover what code is needed. So you're going to type what you think you need, and then you're going to discover what's needed by as you type. Like, oh wait, I don't have a name variable. So then you go up here and implement that. So private string name. Okay, so now that's going to go ahead and return that. Now, our constructor, which is what an object or what a class needs to actually construct something, is where we're going to actually assign this value. All right, so constructor doesn't return anything. So public user, and we're going to pass in the name. And then we're going to set this name, which is this name up here. So this refers to the instance of this class, and equals the name that's being passed in. So now if anyone wants this, they're going to pass it in here. And notice that I haven't implemented the login part yet. What I'm trying to do is go all the way through to the end, and then I'll fill in the details of what's left, because this allows me to get to something that's a value that I can test as quickly as possible. I could have tried to type out everything, the person interface, the login interface, but then it's taking me longer to get to something where I can start testing it and seeing if it's working. So I'm trying to get to something that's the smallest thing I can do that actually is valuable to test. So I'm at user, I've got name. So let's go ahead and make that program that we're going to use to test this thing out. And we can call it whatever we want, but let's call it, what was it? Test. I have no idea what it was called. Let's just keep the names consistent since this is a tutorial. User service, that's something we need, but not yet. So test user login. So that's what I'm going to call it. So this is the class that I'm starting now. Test user login.java. Let's save that. Okay, and this is a public class. Test user login. Now this is going to be our the actual entry point of the program. So we need a public static void main, right? And it's going to take a string array of arguments. Okay, and this is our entry point. So this is the thing that we get our actual run and debug. So now we're going to start testing out some stuff. So this isn't the real code maybe that we're using. So we have a new user which we have here, and it implements person, so it's going to have a name. So let's go ahead and just type in Wally, because that's what our example had. All right, and then let's assign this by using, I used command dot, and then you can use control dot if you're on Windows, and we're going to have a user there. Okay, so now we've got the constructor. It's actually being tested. Let's go ahead and system out printline this. Now this is going to probably be throwaway code, maybe. I'm not sure. I'm just trying to implement something and get to something testable. Let's go ahead and run this and see if we get... Okay, so user just printed out the user object. So let's do user dot get name, because that's the interface that we wanted, right? Interface method or function we wanted. And it printed out Wally. Okay, so now we've got that going for us. All right. We want to log in this user. So at this point we can create the user. They're not saved anywhere, but we could actually create the class. Let's go back to the tutorial now, because I'm starting to forget what our purpose is. And this is kind of the definition. Okay, so we want something that logs people in and is for our user. So we have a user, but they need a login. At this point, would I implement the login part now or the service part now? I would probably do the service part now, because the code that we have now is just creating an object user and just spitting out the name. Anything with the login part is kind of not very useful yet. But creating starting to fill in the logins, the user service with authenticate, starts giving us a purpose for adding the login. And so as long as we have a purpose, it'll help guide us along the way. So now this is thinking like a programmer, thinking like a software engineer, trying to figure out what the purpose is and let the purpose drive what you're coding. Because if you're just implementing stuff, it's kind of hard to think about. Where if you actually have a purpose in mind, then it guides you as far as the thinking goes and what needs to be done. All right, and let's try and keep the names consistent, at least for me, because I'm trying to share this with other people, and I've written it down this way. Okay, so it's going to be a user service, and it's going to have a user. So let's just go ahead and start that off. So I'm going to start a new class, and it's going to be a public user service. Oh, wait, I need to save it as Java first. So let's go user service.java. Okay, and that's a public class user service. Okay, and it doesn't need a constructor. I gotta tell it's a class, otherwise it's gonna complain. All right, and it has users, right? So this is our user service, and we're not using a database. Otherwise, this would be accessing a database. But we're just gonna use a map as our database right now. And you remember map from one of our other lessons. So the map, we're gonna key it off of the username. Someone's gonna log in with their username and have a password, and we're gonna store the user. So we want to store the user by their email address or their username. So let's go ahead and call that a string, because that's what an email, I'm assuming email address, it could be name, but let's assume email address for now. And we're going to store the user. Okay, so that's, we're going to call users, and let's make a new hash map. You guys remember that from one of the other lessons too. Okay, and so now we're going to use a static code block to initialize this, and let's actually make this static, so any instance of user service will be able to access this. And let's make it public. Actually, we don't have to make it public because it's visible. So let's just make it private, and we don't want anyone accessing our users directly. We're going to be the ones interacting with it. So in this case, we're going to make a new user. So here's where we're going to call new user, and it's going to have name. Now you're going to see where this purpose comes in. All right, so new name, and let's assign that to a local variable, and then let's add it to our users map. So users dot put, right, for a map, user dot get name. That's the name. I actually want it by the login username, right? So see how the purpose is being driven by what we're trying to accomplish. So now we need a login. So it's okay to leave this off for now and go and implement the rest, because now this is actually driving what we're implementing. So our user class needs something. So our user class needs to implement a login, and this is where we start making the other things. So now our other interface we need is called login. Now that class doesn't exist yet. So some IDEs will prompt you, and IntelliJ, so when you start writing more intensive Java programs, a more powerful IDE might be useful. There's probably a way to get it to do it here. I am just not sure what it is. And we're learning, so let's type it out for now. So we need a login interface. So let's create a new class, and we're going to call this one login.java. And then we'll make our interface. So this is a public interface. That's called login. All right, so you could also, we know what methods or what functions we need. We need a get username, and we need a get password. But let's let the purpose drive what we actually fill in here. So starting to work like a software engineer, starting to work like a programmer. Let the purpose drive the program. So let's start filling in our user service, and it'll help drive what we need here. So our user is going to be added to our users map. So users dot, and we're going to do put. And now we need user dot, and what do we want? Get name isn't what we want. We want get username, because this is the username that we want to map our users by. All right, so we don't have that function, right? So let's go ahead and add it to our login interface. So we need a string get username, and it's a function. Okay, so now we have to go to our user class and add that. So IDEs help you do this, but this is good that we don't know how to use this IDE in this way yet, because it's forcing us to learn how to do this without the help that might hinder us from learning. So then username. Now remember, we're working almost, it's like working backwards, but it's allowing the purpose to help us figure out how to implement this. So username is not a variable that we have yet up here. So we're going to go ahead and fill that in. All right, so now we've got a username there. Our username's not getting set by our object, so let's add it to our constructor. And we'll assign it here. Okay, so now we've got username on our user, so let's go back to our test program. And this is almost like test-driven development. I'm not teaching you unit testing yet in this set of lessons, because that's a little bit more advanced topic, but that is actually what we're doing right here. This is called test-driven development, but we're not actually doing test-driven because I'm in the user class. What I would actually be doing if we were doing test-driven development is we'd create a test, which is kind of what this one is supposed to be. and we'd be filling it in that way. So we're actually doing programming this way. So we've got our user service and we're just working kind of backwards. But it might be valuable by the end of this set of tutorials to start doing test-driven development, just to show you what that's like. And maybe in our last exercise, we'll do it that way, because that makes more sense to me for learning. All right, so now we're going to go ahead and put our user here in the value. Okay, so now we've got this. We're adding our user to it. So let's go ahead and just, this will be throwaway code. Let's see, out.println. And let's just print out our user's map, just so we see what it is. All right, so that's putting this here. We've got a user service, so that should print out somewhere, I hope. And let's see. If it doesn't, we'll figure it out. But we're doing this. We don't need this anymore. And so I actually don't know if anything's going to happen with that user service and this printing out. It's a static class. We'll access it and see if anything happens here. Okay, so let's go ahead and access it here. Let's do user service dot, and we don't have actually anything to do here, right? We've got a static class and a static initializer, which needs the static keyword to initialize anything. All right, so that'll run static, which means when a class is first introduced and used to create an instance, it's going to run static things. And a static thing is, this is available to all instances of this class. So anytime we create a user service, these things are here. So let's go ahead and create a new user service and see if that prints out anything. I hope it does. In theory, it should. It started to do something. Unresolved compilation problem cannot resolve. Name cannot be resolved to a variable. And it's saying it's in the user service init. So can I click on that and jump to it? Apparently not. All right, so it's saying add our user service line 8 in user service. So line 8. Yeah, where is name? That's because we're creating this right here on the fly. So name is actually Wally. And our constructor also has a username at gmail.com. Okay, now let's see what happens. So at least it's going to print something once we get it working right. So let's go back to our program and run it. All right, so there's our kind of database, and it's got the user right there, and it's wally at gmail.com is equal to that user. So that's pretty much working. So now let's let our purpose keep guiding us. Our user service doesn't need to print that out anymore. All right, so what's the next thing we want to do? We're going to want to log somebody in. So let's go ahead and start filling this thing in now. So now we, oh, did I just delete the user service code that we had? All right, so we've got a user service. Let's assign it to a variable. All right, so we've got our user service. And now we're going to start using the user service to authenticate someone, which just means they're logging in. So our user service needs to have this function, which does not yet exist. And we're going to want to pass in the username. So gmail.com for Wally, and the password, and A, B, C, D, E, F, G for fun. All right, so then, and let's say it passes us back a login object. That's what we had there. And we just want to know that we got a login object or not. All right, so now our user service does not have an authenticate function, right? Because we didn't implement one. So now that's going to drive us to actually create one. So we want that to be public, and we're going to return back a login, and we're going to say authenticate. And it's going to take in the username and the password. Okay, and so how are we going to do this? It wants us to return something. So we can simply do this if we want to return something now. And in unit testing, this is kind of what you would do. So you'd return null, and then you'd run your test, and it would say, your test should say it wants a actual login, and if it returns null, it'll say, okay, your test failed, now you have to make it work. All right, so to make this work, though, we want to get our user, so we're going to use users.get, and we're going to get it by the username. Now, I wrote those classes out in the tutorial. Now we're actually implementing it as if those weren't written, and we're doing it from scratch. So you're learning how a programmer or how a software engineer thinks to build a program that they kind of conceptually know what they want to do, but haven't done it yet, or hasn't made it yet. So now we're going through that thought process. Okay, so this get is going to return type user. So we want to define a user, and that's what's going to capture that. Okay, so then what do we want to do now? We want to make sure the password is right. So if a user dot get password, because we got a user, we think. We don't know, actually, and we'll need to check that. So there's the user's password, and we've got a password coming in here, so we want to see that they're equal. So let's go ahead and use the password that's coming in, because we know that probably has a value. And we'll see if it's equals the user that we got from our pseudo database, and make sure those are equal. And if they are equal, we'll then return the user. If they're not equal, we'll throw a new exception. Let's make it a runtime exception. Not that it matters, but runtime exception will exit the program, kind of, or at least it tells us that it should exit the program. Okay, so I see something wrong here already, and I don't know if the tutorial code has this in it. There's a possibility that this username coming in here will not match anything in our database. And if that is the case, this user will be null, and this will throw a null pointer exception. And we could test that out, but let's just go ahead and do what we know. So the user must not be null, and the password must be equal to return the user. Otherwise, it's going to throw this exception, because either the user wasn't found or the password wasn't found. And in this case, we can just say authentication error, or credentials do not match, because you don't want to give away in security stuff, you want to give away the fact that, oh, okay, those credentials are right, but they don't match. So that way you aren't giving anyone information that, okay, I got a username right, now I just have to figure out the password. Credentials do not match. So that way it's not really telling them anything. And I don't think I put that in the tutorial, but let's go ahead and run that here. Okay, so we've got that. And let's run this. Okay, so our authenticate takes a username and password. Are we there yet? Username and password. Let's see if we get a login. And let's see what it prints out. Okay, so method password is not defined for type user. Well, that's interesting. So this program's actually helping us now that we don't have some of the things that we need. So, yep, get password is in fact not defined, and neither is the password there. So we're actually missing some parts. So our user service is where we're building the user out here. It needs to actually pass in the password. A, B, C, D, E, F, G. We're just having a fake database here, right? So that's added there. So then on our user, let's go ahead and add this to our constructor. And we'll store this for our object. And then we're going to go ahead and allow someone to read that. And this would be done better as test first development, so you could see it in full. But again, that's probably too advanced right now for this lesson, so we're just going to do it this way and get the learning experience in here. So get password. So this is allowing the broken program to guide our implementation, because we have to fix things that are broken. All right, so if we run the program now, what's it going to do? It should be another error, I'm guessing. Password cannot be resolved to a field, and that's in our user service, or in our user, sorry. Let's see, we've got password here, password here. Didn't create the field, which is what it told us. So the errors are guiding us. All right, so now we've got that password. Then let's just run it again and see what happens. Oh, we got a user back. That's pretty cool. So it's actually working now. And let's go ahead and see. We've got the user, so let's see their username. Let's see which one we got. We know which one we got because this is the one we passed in. So let's go ahead and run that. And it should be wally@gmail.com, which it is. All right, so now let's go ahead and, instead of getting the username, so we've got a login. Let's go ahead and do this. Let's get this as a user. And we're gonna cast it, because that's what we did in that tutorial write-up. And we're gonna take login, and we know it's a user. Sometimes you don't know that, and we might want to write some other program, but let's just keep it simple for now. We know that login is in fact a user, so we're gonna cast it to a user so we can access the user get name function. And let's go ahead and run that, and everything just fell into place. We got Wally. So now let's go ahead and say hello. Hello, Wally. And we'll run that. Okay. I'm actually a little surprised myself, because that filled in rather naturally as we just went, and it filled in the program. It might be close to the tutorial definition. I think it probably is pretty close, and so we implemented it from scratch as we went, and it might be the same, it might be a little bit different, but we actually did it without referring back to the tutorial. I think we actually made an improvement here too, because I think this would be a problem. So let's go ahead and test that out. If we try to log in somebody that's not in there, let's say Bob@Gmail, and I think we're going to get a program exit is my guess. Let's see what we get. It's got a runtime exception, credentials do not match. So we got the error that we were expecting. So let's put Wally back in here. Okay, it's working. So that's how you think like a programmer, think like a software engineer, implementing a solution by letting the purpose guide your programming, and letting errors, and if in the case of test first development, letting test failures guide what you need to implement. And so that's kind of how programmers and software engineers work. That's it. Thanks for watching.